Okay, this is Unit 12C. We are looking at apportionment, the House of Representatives, and going to be on that. And apportionment basically is a way we're going to be used to divide things up. So each state in the United States has 2 senators, but the number of representatives varies state by state. And who decides how many of and there are 435 seats in the House of Representatives. So who decides how much each state gets? This question is one of what's called apportionment, because the seats in the House of Representatives must be apportioned or divided among the states in a fair way. And so this unit, we're going to be looking and discussing some of the mathematics that underlies how this is done. So there's your formal definition of apportionment, and it's not just for the House of Representatives, although it's a great application there, but it can be done in other ways. So, the requirement for the House of Representatives are pretty complicated. The Constitution mandates that seats in the House be apportioned to states according to their population, subject to a minimum of 1 seat for every state. So every state gets a minimum of 1 seat no matter what. So they get some kind of representation. And it allows Congress to set up the total number of representatives so long as the total number does not exceed 1 for each 30,000 people. We don't want to have too many representatives in there. And the Constitution directs Congress to reapportion seats in the House every 10 years following the census. And so, Utah has actually gained a seat in recent years as the population in Utah grows, and then you have other states that have actually lost quite a bit. If you look over the last 20 years, the state of Michigan has lost a substantial amount as their population has decreased. So this does readjust with the census. The thing that the Constitution does not specify, though, is the procedure for the apportionment. And as we'll see here in just a moment, it's not easy to choose an apportionment process, and there's no single procedure that is always perfectly fair, and it depends on your definition of fair. But we'll look at one called the Alabama paradox, which is you can see where some fairness definitely may become in question there. But let's look at this question first. So representation in Congress. If the population of the United States increased to 350 million, which is the projected population 2030, the number of representatives remained at 435. How many Americans on average would each representative serve? So if we're looking at this question here, and again, we've got this population of 350 million approximately, and we only have 435 in Congress, then we would take our 350 million, so that's 350 million people, and divide that by 435 representatives, and this comes out to be about 4,598 people per representative. Sorry, that says people per representative. Couldn't fit it in there. So this is pretty far off from that minimum of 30,000. So with this population, if the number of representatives were at the constitutional limit of 30,000, of 1 representative for every 30,000 people, how many representatives would there actually be? So if we were to bring this number down to 30,000, essentially is what this question is asking. We wanted to know what it should be, how many reps there should be with 350 million people, so that we're at that minimum threshold of 30,000 people for every representative. Well, then we would just take our 350 million projected population and divide it by 30,000 people per representative, and this turns out to be about 11,667 when you round up representatives. So you can see that this is way bigger than the current 435 reps that we have right now. But if we were to be at that minimum at that time, the number of representatives would be huge, and it can make it a very complicated and complex process. But that's kind of showing you where the minimum threshold is and where we actually are currently now. So when we look at an apportionment problem, so we're going to look at it in example 1 using the 2010 census data. Each House member represents an average of 710,000 people. That's in 2010, that's where it was. And again, we saw the projection for 2030 to be about 804,000. Now, apportionment would be really easy if population states were simply a multiple of whatever that number was, in this case 710,000. For example, if a state's population was 1.42 million, that's double the 710,000, so that state would get exactly 2 representatives. Similarly, if a state's population was 7.1 million, then they'd get 10 representatives. But it's not that convenient. For example, in the 2010 population, Rhode Island had 1.05 million people, and so that's about 1.5 times the 710,000. Again, 710,000 people per representative, so they're about 1.5 times that. So they're entitled to 1.5 representatives, but I mean, you can't really have half representatives. So Rhode Island could have 1 or 2, but not 1.5. Now, the people of Rhode Island definitely would prefer to have 2 representatives because that strengthens their voice in the House of Representatives. However, other states might prefer Rhode Island only have 1, thereby leaving 1 more representative for some other state who, Rhode Island may have 1.5 representatives is what they should be allocated. Another state may have like 23.8, so their fractional portion is closer, and so they might argue, well, we should have more because we're closer to that threshold. And so apportionment problems deal with finding a systematic way of deciding whether, in this case, Rhode Island should get 1 or 2 representatives. It's got to be fair to all states, as fair as possible, while ensuring that precisely there are only 435 seats awarded in total. So here's kind of a look at how this process begins. So, again, we look at Rhode Island was entitled to 1.5 representatives. So first, here's how we're going to do this. We're going to divide the U.S. population by the total number of representatives to find out that each representative in 2010 served 710,000 people. Okay, then we divide, in this case, again, we're sticking with the Rhode Island population. We divided Rhode Island's population by 710,000, and that turned out to be 1.5. So in the terminology of apportionment, that we say the 710,000 average is called the Standard Divisor. This is what we're dividing the populations by. The 1.5 for Rhode Island is what we call the standard quota of representatives for Rhode Island. It's the number or the quota that Rhode Island would get if it were possible to have fractional representatives. And note that there's only one standard divisor. That standard divisor is applied across all states, but each state gets its own standard quota. So here's, again, the standard divisor. There's only one. It's the total U.S. population at that time of the census divided by the total number of seats. And then that's for the U.S. as a whole to get that divisor. And then we go down to the state level. So the standard quota, you take the state's population and you divide it by the standard divisor, and that tells us the number of representatives as a fraction that each state should get. So the standard divisor and the standard quota also apply to, apportionment problems besides the House of Representatives. And so we'd simply just replace number of seats by the number of items to be apportioned to a state, and total population by relevant population. So if we're not looking at the House of Representatives, but we're looking at some other, we've got a total number of items and they need to be distributed or divided amongst a certain number of entities, we can generalize this to more than just the House of Representatives. But this is a very, very applicable, the House of Representatives is a very applicable application that we can use and that is used. So We're going to look at some problems here. Well, we're going to look at just one of the states, Georgia. So the following number shows the 2010 populations for 4 states and the number of seats in the House of Representatives. We're going to find their standard quotas for each and compare it with the actual number of seats. And then we're going to determine whether the state is relatively under or over-representative in the House. And the U.S. population at that time of the census was about 309 million. And again, there are 435 seats in the House. So we're going to look at Georgia. So again, the first thing we need to find is the Standard Divisor. And this is going to apply to all states. So you take 309 million, your population. We're going to divide it by the number of seats, 435 seats. And here's where they got that approximately 710,000, but it was 710,334. And I'm going to round this to a couple decimal places. But that's our Standard Divisor. And this is going to help us now find the standard quota for each state. So we're going to look at Georgia in particular. So the Georgia standard quota. Okay, we're going to take Georgia's population, which is right here in our table, 9.6-ish million. So 9,687,653. That was their population of the state. And then we divide it by the Standard Divisor, which is 710,334. I'm going to use some decimals here just to make sure we're accurate in the end. And when I divide that out, I get 13.64. So their apportionment should be 13.64. But if we look here, the number of seats they have in the House is actually 14. So they were able to get rounded up. So in terms of their representation, they are actually overrepresented because their standard quota was 13.64, but they were able to, in this allocation apportionment, they were able to get 14 House of Representatives seats. So they're a little bit over-representative. Okay. Again, now this idea can apply to more than just states and the House of Representatives. So in our next video, we'll be looking at standard quotas in education. We're going to be allocating academic advisors. So stay tuned for that in the next video.